Hi, it's Dr. J here. In this video, I will solve question 15 of the 2021 WACE paper. It is a standard projectile motion question, which you should be able to do in less than the time allocated. A 42.5 kilogram gymnast performs her dismount from the 1.25 high beam. She leaves the beam with a velocity of 3.10 meters per second at an angle of 55 degrees to the horizontal. There is a picture, but the online version of the picture isn't printed. So I'm just going to draw in here what it is. So something like that. And the height of the platform is 1.25 meters. I'm going to draw in the velocity over here. So they've told you that it is at 3.10 meters per second and it is at 55 degrees to the horizontal. So this would be your UX. And this will be your UY. Now, if they hadn't asked me in the first section, which says calculate the vertical and horizontal components of her launch velocity, I would actually do that straight away at this point here. So you always need that, so it's always worth doing. One of the other things I'll put in here is I will put in this quantity here, which is a range of x, and at this point here, SY would be equal to minus 1.25 meters if we consider that SY here is equal to 0. Okay, so just to help you remember. Okay, so calculate the vertical and horizontal components. So UX would be equal to whatever velocity they've given you, cos of 55 degrees, and so I've got 3.1 cos 55, and that will give me 1.78 meters per second, and then UY is equal to U times by the sine of 55 degrees, 3.1 sine 55, and that gives me 2.54 meters per second. So nice and quick, very straightforward. Okay, calculate the time it takes her for her to reach the ground, assuming she is vertical at impact. So this is where we're going to focus on the vertical components only. So the distance she travels downwards is 1.25 meters, and I'm going to put down a negative because it's down from where she started. The acceleration she has is due to gravity, so it'll be minus 9.80 meters per second squared. The initial velocity in the y direction is positive because it's upwards, and it's 2.54 meters per second, which we calculated before, and we're looking for time. Now, if you go through your equations of motion, you've got v squared equals u squared plus 2as. From there, we would find v is equal to u plus at, so we would find the time it takes to get to that particular velocity. So that's one technique. The other technique that can be used is s equals ut plus a half at squared. This will lead you to using the quadratic formula. I would avoid that if I were you, because when you're a bit stressed in an exam, you tend to make mistakes with big equations. So if you can avoid it, do so. All right, so let's go with v squared equals u squared plus 2as. And I've got 2.54 squared plus 2 times minus 9.8 times by minus 1.25. Do you see how important those minuses come in? Okay, now what this means, if I pop that through my calculator, I'm looking for v, so I'm looking for the square root of, and remember it can be plus or minus. So that turns out to be 5.56 meters per second. Okay, and which one would it be? Well, he's going downwards, so therefore it's got to be minus 5.56 meters per second. That's really important, getting that minus in there. Okay, so it's got to be down, so it's got to be negative. Then I'm going to find out sorry, let me just put in some subscripts there. I forgot to do that. So then I've got Vy is equal to Uy plus Ay times by T. And I've got minus 5.56. And then I've got Uy, which is 2.54. And then I've got plus minus 9.8 times by T. So you can see here, if you end up with a negative T, you've made a sign error somewhere. So T would be equal to minus 5.56, take away 2.54, divided by negative 9.8, and that gives me 8.27 times 10 to the minus 1 seconds. Now the wonderful thing about finding time is that that time in the y direction has got to be the same as the x direction. So in this next one, we're looking for the range, and that is Sx. So that's what we're looking for. Remember that in the x direction, we're assuming that there's no air resistance, etc. So there's no forces acting, so therefore your velocity will be constant. So we're then using V is equal to S over T. So our UX is 1.78 meters per second, and we know that the time is 0.827 seconds. So that's awesome. So we've got SX is equal to UX times by T. So I've got 1.78 times by 827, and that will give me a value of, if I pop that through my calculator, 1.47 meters, and it will be to the right, okay, or forward. All right, next we're looking at the gymnast's kinetic energy at the top of her flight. So kinetic energy is half mv squared. Let's think about her flight. So her flight is like this. At that point there, she will still have a value of ux. So we still have that, but uy has got to be equal, or vy rather, has got to be equal to 0 because we're at the top of the flight. So we're heading downwards from there. So we should just have a half times by m, which is 42.5 kilograms, and v x squared, so that's 1.78 meters per second squared, and we then have 6.71 by 10 to the 1 joules. There you have it. So we have managed to finish this question in quite a short period of time. 11 minutes was allocated. We've done it in less than 8 because I did some explaining along the way, and so it's a bit of a bargain question again. Okay, so in this video we solved question 15 of the 2021 paper. We've gone through the standard things of working out the components of velocity. We then worked out what the time taken to reach the ground is. We looked at 2 possible ways of doing it. I try and avoid using the quadratic formula if possible. And then we needed to calculate her range. So remembering that in the x direction, the velocity is constant. And finally, we worked out the kinetic energy, and there was just the realization that Vy needed to equal 0 at that point. Thank you for listening to my video. Remember to subscribe to Dr. J for the latest physics tutorial, and if you have any special requests of problems you would like me to solve, please leave a comment in the comment section. Thank you.